And I also find it useful to make sure you keep like the URL or some way that you can remember where you got the data and go back and find it. So yeah, it's something I'm dealing with right now. Basically the same rules except for authorship, I think. For analyzing the data, if you have other people analyze the data, it's good to have kind of standards made by all parties. So for me, I got microsatellites, which in the lab they were measuring allele size, and I sent one population off to a foreign lab for them to run it. And I had to send them standards to make sure that they were calling the same fragments, the same length. So an example would be like interviews that are coded differently by different people. So if you have a bunch of people coding, make sure, hey, so test and look out for that. And this was the example of, even though I sent standards off to the lab and it came back that they were calling the alleles the same, obviously they weren't for this particular locus. You can see like it was a 10 population that I sent off. They're all off by 1. So it's good to really know your data and take a close look at it. So. How to avoid disasters, basically kind of repeating myself, know how it was collected, know the assumptions, the caveats of it, limitations. When I was comparing the subsistence household surveys to the hunter tickets, moose hunter tickets that people turn in, talking with the researchers, there's just when you're kind of looking, what I did is I looked at like the % of people in an area who are rural versus urban spatially, and with that you kind of have to understand that you're naturally going to underrepresent the rural population because they are less likely to report their moose harvest, just because of forester management, and also they're more likely to be reporting close to where they live. So, that was an underlying assumption that you kind of have to make clear. In my manuscripts, lots of times I will just have an assumptions limitation paragraph in the methods. And always save the original file. The very, very original file is a good idea, and archive that. Also, save the database with the new name when you make changes. There was a big database at Fish and Game, and someone had went through and sorted it and saved it. And in Excel, if you don't have continuous data in the columns, it's not going to match and sort the same, so that caused quite an issue. I'm always leery now with sorting in Excel. Yeah, I copy it to a new spreadsheet, and that's where I do my sorting, and I leave the existing database alone. So, I've been burned by this one. Always watch the total number of rows in your database. ArcGIS database imported into a different program, like say SAS, might not be able to hold the same number of records as what your ArcGIS database does. I know that's happened to people when they export a table and they try to open it up with Excel, because Excel doesn't hold nearly as much as what ArcGIS does. So it's always a good idea to just scroll down to the bottom and make sure all your data is there. Plus, if you're dealing with like ArcGIS, you might have accidentally done a search, so some of your records are highlighted, and the ones that aren't highlighted are going to be excluded when you go to export the data. You'll lose them. So, and know how null values are handled. Is that blank just data wasn't entered, or is it actually supposed to be a 0? And different programs handle null values differently, and I found, where is it?
Can I throw in a brief horror story about that?
Yeah.
My children while they were in high school, took classes elsewhere, like being a foreign exchange student, going to summer school. They had
academic credits from these, they were pass-fail. The school entered them into its database. It didn't have a way to handle pass-fail, so they all showed up on the record as being Fs. And my daughter came back from a year in Finland, and she had been at the top of her class, and they had this little printout, and they went, oh, you're ranked 88th in your class out of 110 students. And we were just, what?
Wow.
And it actually happened then to my other daughter with summer school credits. We got a statement from the school where on her class ranking, and I said, this just can't be right. Her GPA's been going down instead of up when she kept getting A's. And I went in and talked to them, and it turned out that that was the cause. So they were both ineligible for the state scholarships for the university system because the numbers were set in when they were juniors, it was the wrong numbers. So that problem is very near and dear to me. Very real.
And later when I'm going through kind of designing database, I'm going to kind of show some things of how to avoid, disasters with null values. So I'll kind of get into that. But yeah, null values can be quite the pain. And there's ways to avoid them and deal with them. Also, it's a good idea to, if you have like categorical data, to check the different levels in your categories. Because like this is a code in R for a database with a column named vendor, and it's supposed to be just yes or no. And just doing a simple search like this, I can see, okay, someone screwed up. There's not supposed to be a Z in there. And before I run my analysis with a Z, also, that's just a code for SAS when I'm looking at the different category levels in SAS. And what? I know, no observations is what it stands for. And this is an example why you want to check the category levels because the one on the right-hand side, the degrees of freedom are 8, and the one on the left has 7. And obviously they give you different statistical results here. I mean, they're both significant p-values, but it might not be. And what happened was I was looking, and these are transportation modes, and someone put in HR, which kind of represents horse, but the way the data is supposed to be, a horse is supposed to be the same as a foot. So then I removed it when we had the correct number of categories. So I always snoop around and do that. And it might seem straightforward here, but imagine you have a big model with a lot of categorical parameters in it. You might not go down and look at the individual estimate output, and so you might not know. I've seen that happen before. So data snooping is really, really important. Running your histograms, your box plots, stuff like that. Do that all up front. Statistics.
What output is this? What program is this?
This is SAS GenMod.
Oh, that looks really nice.
Yeah, I found a little code that you can put in the beginning and the end of it that gives you this nice output. And yeah, there's different types of outputs that you can give. Some are journal style, and I forget what this one is, but it's much better than the regular SAS output.
Wow.
So I can show you and send you the codes. But yeah, and that's what I primarily use is SAS. I've done some stuff with R, but not too much.
Are you statistically geeking out on me right now?
I think she is. Okay. Now I was going to kind of go into database design, but what I was going to do is kind of divide you up into 2 groups and give you a research kind of a question and see how you would develop the how you would develop the database. What tables would you use? What columns would you use? And if we just want to split it in half. And I thought you could just talk like for maybe 5 minutes or something and come up with maybe a little picture or something about how you would analyze this problem. And I can explain it to you more